All right, did anyone pick up the Daily Bruin this morning?
No.
You should. My friend, Professor Katsuya Hirano, is on the cover, and it actually talks about a collaboration that I'm having with him while visiting this particular site this summer, which is a topic of our project here, the Fukushima nuclear disaster, that, as many of you probably recall, we call it in Japan 311. So this is kind of the equivalent, I would say, of our 911 here in the US. It is that much of a catastrophic event. It remains in our history and in our memories. And tomorrow is the 5-year anniversary of this event. So it's a very timely project. It's a very relevant project. You will hear it all over the news today and tomorrow. And then it'll disappear completely. Everybody will forget again until next year. So our study area is in Fukushima. Aaron made this beautiful video of, I think we all know kind of where Japan is, hopefully, South Korea, North Korea over there. Fukushima is in the eastern coast of Japan. The nuclear power plant sits right on the edge. The tsunami, the earthquake happened right around here. That's the epicenter of the earthquake. And a few minutes later, the tsunami came in and swept away, as maybe we recall, lots of communities. And it also caused the catastrophic nuclear accident where 3 reactors exploded on March 12th, which is the next day. So this is what we are investigating in our project. To give you an idea of what it looks like inside the so-called evacuation zone, that red zone that we just saw is a 20-kilometer imposed zone where people are not allowed to go in, and 100,000 people who lived there were forced to evacuate, and they're still evacuated today, most of them. This is a town that I visited last year in December, and this is what it looks like. So to give you an idea, every entry point, there's security guards everywhere, and it's a ghost town, basically. This is a ghost town. Nobody's living there anymore. We're going to do show some nightlight, nightlight analysis to show how much light has disappeared. This is kind of a drive-through. We have 2 GoPro cameras on a car. This is what it looks like inside the zone. You can see all the vegetation. These are all rice paddies on either side of the road. These are boats, abandoned boats that have been, this is about half a mile inland, so you can kind of imagine just the impact of this disaster has had upon these communities that have been abandoned. And so this project largely seeks to measure, what can we measure about abandonment and these ghost towns using remote sensing. So it's one thing about being there on the ground, but what can satellite tell us, and especially with this great course that we're learning about remote sensing. So this is kind of like the end of that route. Everywhere in Fukushima where you go inside the evacuation zone, you will see these measures here that actually detect airborne radiation. That's 13.1 microsieverts per hour. We want that value to be under 1. So you can kind of tell this is one of those areas inside the zone, and this is measured last year. These are super high radiation areas. And you can see all this shrubbery is because nobody has been there for 5 years. All right, so our question, a research question, asks, how has a nuclear catastrophe affected the spaces that surround it? Well, we're going to do a 4-point analysis, and I'm going to kick it off, and then I'm going to give it up to my colleagues here. The first thing is changing greenness. So this is F1, the Fukushima Daiichi nuclear power plant in 2004. A lot of green in the south side here. All that green actually disappears. We have all these canisters here. They are storing radiated water, and and also all these rice fields around the Fukushima nuclear power plant, abandoned rice fields over there. And then compared to abandoned rice fields, if we go 90 kilometers north in the city of Sendai, where a lot of people evacuated, we now have healthy rice paddies. So doing kind of an NDVI analysis over healthy versus abandoned rice paddies. This is just kind of an NDVI measure over the course of 10 years taken on the abandoned rice paddy as compared to the one on the healthy rice paddy in Sendai. And then you can kind of see in the healthy rice paddies, it's kind of very flat across 10 years. Whereas in abandoned areas, it kind of goes up. So it kind of actually shows the greenness increases in abandoned rice paddies, which kind of makes sense. When you don't actually do anything to an agricultural pasture, it's just going to grow more green. And just to give you an idea, this is kind of statistically significant, something we want to measure in more detail. If we were to take 5 years worth of NDVI values inside the evacuation zone and get the median of all 5 years of that vegetation, compare it to 5 years after the disaster, and then we can create this kind of a change map before and after. This red zone here is the Fukushima nuclear power plant. There's a lot of red because a lot of construction and rebuilding is happening. A lot of these red areas along the coast also represent areas where there have been a lot of activities in terms of storing radiated soil and so forth. So they've lost a lot of greenness. All right, so now we're going to talk about rice.
So as Yo was talking about, agriculture is one of the principal economies of the Fukushima prefecture, so we decided it was one of the important variables to measure the extent of the Fukushima nuclear disaster's effect on the area. And what we wanted to do is we wanted to find a way, can we find a way to visualize the agricultural rice paddies around the area, and can we measure the extent of their abandonment? So basically what we did here in this map is we took the 20 km evacuation zone and we underwent an unsupervised classification through ENVI. And the problem with this method is that there's a little user control in how these classes will be identified, because essentially you leave it to the computer to decide the characteristics of the classes. So we did the unsupervised classification, and these were the classes that were closest to identifying rice paddies. The problem was is it wasn't completely accurate. Some of it bleed over to, like, say, urban areas or mountain ranges. So instead, we did a supervised classification through ArcMap. And essentially what this involved was that we had to basically train the computer and tell the computer, okay, we're going to draw out at least 100 polygons of what a rice paddy is. We're going to draw at least 100 polygons of what an urban area is, what a water area is, and what mountain ranges are. And this is the result of our unsupervised classification. And essentially you can see just how important the rice paddies are in the area, and it made up to be about 50% of the land cover area in the 20 km evacuation zone. Next map. And you can basically see how important agriculture is in the area as identified by the light green.
Okay, so this is Dimitri's stuff.
Yeah, so our other group member isn't here, but we have his maps. Here's pre-disaster. The population change doesn't seem to vary very much within the zone, but outside the zone there's a little increase. We look at the year of the accident and the year after, it seems like there's a lot of variation because there's a lot of, outside the evacuation, there's a lot of people leaving and or coming in. It's hard to tell because it's very mixed.
Basically you can see that the disaster was kind of a catalyst for a lot of movement outside the area.
This 2012-2013 map shows a lot of decreases within the zone, which is kind of curious because it seems like there wasn't any data previously to that area within the Fukushima. I'm assuming that they started collecting this data after the accident because they wanted to keep track of what was going on and have more detailed information. And 2013-14, it shows a lot of increase, which is quite surprising, but I guess it's along the lines of time changing and allowing people to move back in, which I'll get into in my maps. So nightlife activity. I chose to do nightlife activity. There's a little arrow pointing to where Fukushima is in comparison to the rest of Japan. So I used 2013 years and 2013-2015 years satellite data, which is a little more high definition. Here's red, which is an increase, and blue is a decrease in nightlights. I chose to do night activity because I wanted to look at how many people were actually moving back into the area and staying, or whether it was legal or not. And if we move to the next one, we can see there's this pretty large increase in the southern part of the evacuation zone. And this city is the city of Naraha. And it was, in 2015, it was the first city to lift entirely all restrictions to living within the evacuation zone. So people can move back into their town there, which explains why there was so much increase. And so our conclusions in the future, we are really surprised and glad to see what kind of remote sensing can do for us in this kind of analysis. And we're kind of looking forward to the future with all these fancy new satellites attached to the International Space Station to hopefully gather more detailed information about the area and hopefully even be able to detect nuclear radiation and nuclear contamination of soil from space one day. Thank you.